Welcome, everybody. This is going to be a discussion of chip number 35 from Michael Taylor and from Yak. We have both of them here right now to discuss it. And this chip is adding data layer delegation capabilities. So before we get started, Yak and Michael, would you mind introducing yourselves and let us know who you are? Yak, you want to go first?
Sure. Hello, everyone. I'm Yak. I'm mostly known by my work on the bridge as well as Tibet swap. Uh, and yeah, I wrote a lot of puzzles.
Nice. And Michael?
Hello, I'm Michael. I originally worked on the CAD-T project and since have continued working on data layer in general, looking for ways to achieve wide adoption of the technology. So always researching like how to improve it and so on. And that's kind of how this chip came into being like during that process.
Great, thanks. And just so you know, I'm Dan Perry, and I work at CNI, and I tend to be the editor of most chips. So I'm just kind of facilitating things here. And if you have any questions about the chip process itself, feel free to ask me on Discord. All right, so Yak, are you gonna walk us through the chip and exactly what it does,
Well,
or would you rather do Michael?
maybe maybe it would be good to give a background on how we came to this,
Yeah, absolutely.
and then jumping into the technical parts of it. Um, so I've been doing trying to find a way to make data layer easy to use, and I've worked with a lot of community members like over the past couple of years trying to get them to use it, and I found that there's in the current implementation, there's a lot of difficulties for usage, not from both the dev aspect and also from the consumption aspect. So a lot of the parts of this chip, they're kind of geared towards improvements that can help with those aspects. So from the consumption aspect, data layer itself is very opaque. Like the only thing that you know about on chain is the store ID, and you don't know anything else beyond that. And I've been working with Space Scan to try to start indexing our stores, and without downloading the entire store, you just don't have a way to glean any sort of metadata about that. So we added optional metadata fields. The fields are completely optional, and but the more you add, the more visible you are to indexers like SpaceScan. We added a couple of standard fields that we would hope are standardized across all of them, including label, description, and bytes. Bytes is also very important so people can make decisions whether they want to mirror your store or not based off of storage space that they actually have. We don't want to find out that is a 10 terabyte store after you download it. You want to know that ahead of time. Um, but we really made the metadata fields kind of expandable, beyond just those three core ones, so that in the future we find out that we need more. Um, it's easy to add. Now, what it's a trade off here because adding these fields does increase cost, but it's kind of the higher that you trade off cost, the more visible your store is to indexers. Uh, and again, it's optional, so you can also just not include the metadata as well at the cost of visibility. So that's kind of like the trade-off that we're seeing here in the fallback. If cost is something that really matters to you, you can skip it all together, and you can find your own ways to make it visible. Next, we added these delegation capabilities. What I found is a lot of developers that want to use data layer just really aren't either in the position to run the entire stack needed to run it, or they want to be able to automate publishing to DataLayer through CI, in which case it's very, DataLayer right now is very monolithic, and writing to a store kind of requires you to have the entire, stack in place, which makes, while not impossible, makes a CI difficult to set up from scratch. So we added this concept of authorized writers, where you can actually delegate access to another key to write to the store on your behalf. And authorized writers only have the ability to modify metadata, including the root hash or any other metadata fields. This way, you can we can start building up business solutions on top of DataLayer, like GitHub, for example, but like DataLayer Hub, and where you can delegate access to that service, and then you can just upload your data to the service, and the service, can write to the store on your behalf. This allows the developer side to be very lightweight. They don't have to do a whole lot of setup. They just sign up and go. Other purposes of authorized writers might be for if your data store is behind a DAO, and you want the DAO to be able to own the store, but you want to vote to allow authorized writers that the DAO agrees to write to it. So there's just a lot of interesting innovations that can happen by just being able to delegate access to write to the store. Because right now it's the only person that can write to the store is the owner of the store, and it kind of really adds a level of centralization to a DataLayer store, and we're trying to add tools to break that up a little bit. And then a variant of authorized writers is authorized admins, which is basically you have all the permissions of the owner, but you just don't own the store. And this is the other thing I wanted to point on is this does allow you to maintain ownership of the store without sending it off to somebody else to allow them to write and then hoping they send it back. One of the issues I ran into when I was trying to build services around DataLayer is if I wanted to really help out the developers, I had to own the store, and I wanted them to maintain ownership. The last layer we added was this is an optional Oracle layer. This is actually really cool, and I really think it will open up a lot of capabilities within our ecosystem. Adding the Oracle layer to a DataLayer store allows you to spend the store, anybody to spend the store in a way that it creates a coin announcement that includes information about the store that other Chia list puzzles can intercept and validate against. So you can actually create puzzles that operate off of DataLayer stores. The puzzle would choose the store that they trust, the store that has the data that they care about, and they would just build into the driver code to spend the store, find that coin announcement, and then to operate, make the new puzzle spendable based off of that coin announcement. So one example of this might be that NFTs, somebody creates a DataLayer store that stores all the rarity scores of an NFT collection, and now you can actually construct offer files that will say, I'm going to offer 5xCH for any NFT that has a rarity score of 5 or higher. just as an example. And then to incentivize, people to build high quality Oracle services, we built into the puzzle that the Oracle provider can actually set a fee that has to be paid for the Oracle service to create that coin announcement. So you actually open up another revenue source for DataLayer, where trusted individuals can maintain high quality data sets that the rest of the ecosystem can now use as part to power their puzzles based off of that data, and the Oracle provider gets paid every time the Oracle is used to power another puzzle, and they can set they can set that payment to whatever they want. Ideally, it's like something that's like small and you make your money in bulk, but like the Oracle provider has full control over what it costs to actually use the Oracle as it as an Oracle service in Chia list. So I hope I didn't miss anything, but I think that's kind of like the high level of the three different things that are in this chip.
All right, thanks, Michael. Sounds like there's a lot of good potential use cases for this and could be used in a broad variety of ways. So looks really great. How about the technical details? I mean, is this going to be just a couple of Chia list puzzles, or is there other code that's included with this chip that you'd want? I guess anyone who implements this chip will just implement that code, or how does this work as far as the technical details?
Yeah, I think I'll just quickly reiterate through what Michael said by following the chip so that people can know where to find more details. So as Michael mentioned, there are three main changes. First of all, we wanted to add some authorized puzzles to a store. So currently, without this chip, only the owner of the store can update metadata or spend it. We wanted to add writers, admins, and oracles. There's also some changes proposed to metadata fields and the memo structure that hints a store. So I think it's best to start with the rationale, especially the current structure of the data store as it's stored on chain. Data stores are also known as NFT zeros because they are actually NFTs without an ownership layer. So this means they have a unique ID that can be used to track them on chain and verify their uniqueness in Chia Lisp. They have a state layer, so every data store is like an NFT, but instead of an image and the license and so on, it stores a root hash. And it also has an owner inner puzzle. So that's the puzzle that allows someone to own the data store. Now, we have three proposed changes. So I'm just going to showcase how they change each layer. We wanted to maintain this chip as backwards compatible as possible. So normal vanilla stores are currently compliant with this chip. I guess I'll just go over the changes. So the metadata currently only contains a root hash. And as Michael mentioned, we wanted to allow explorers or other people to pick up details about the store. So now you can optionally add a label, description, and bytes, and this will be fields like the image URL of an NFT. They will live in that metadata section of a coin. Next, we have the ownership layer. So if you didn't delegate access to anyone, if you don't have any puzzle they can write or rather update the metadata, or if you didn't enable Oracle capabilities, then the ownership puzzle will be the same as if the store was a vanilla store. If not, there is a new puzzle that is introduced with this chip, which is here. So the main repository links, the main chip links to this puzzle. This is called the delegation layer. And here you can see that your ownership puzzle lives in the store, also a list of delegated puzzles. And then the last thing is memos. So when you create a coin on the Chia blockchain, you specify a puzzle hash and an amount. And there's also an optional list of memos. And in the context of DataLayer, what those memos tell you is information about the store, that the new store coin that is being created. So when you update the data store, you use a create coin condition to create the next generation and use these memos to hint what's inside that store. Currently, the memos are hinting the launcher ID, and that helps with indexing. Also, some other things that can be inferred from the puzzle. So we've also proposed a change to the memo structure, which is detailed in this chip. But with these changes, you will be able to pick a span from the blockchain and infer what the new store is. So what's the metadata, who's the owner, and if there are any delegated puzzles, what puzzles are those? Now, because this includes a new puzzle, we've done quite a lot of tests. I think the final number is over 1,000 variations. And this cover everything from launching a data store with custom configurations to transitioning from one state to the other. So for example, updating the metadata and adding another delegated writer. And we have two places for the reference implementation. So first, there's the DataLayer driver repository. And this is what I was just showing to you. Here you can find the puzzles and also bindings that allow you to use this in Node.js. So if I go to npm.js right now, I can search DataLayer driver. Yeah, and you can find this package right now and interact with DataLayer via Node.js. Now, you might have noticed that this is in Rust. The core driver code is written in Rust, so it can be used in other languages as well if you want to create bindings for, say, Python, or if you want to use it directly in Rust. As a matter of fact, we've just merged the reference code in Chia Wallet SDK, so all applications using Chia Wallet SDK can now use utilities for interacting with data stores. And just to show you just a little bit, if I go to Chia SDK driver, you'll have this data store primitive. Let me go to the definition. You'll have this data store primitive that offers utilities such as parsing a span to get the data store coin, recreating it, spending, adding layers, and so on. Yeah, and I think that's it for technical details. Again, everything I've gone through is detailed in the chip. The reference implementations are linked here under the reference implementation section. That's pretty much it.
Okay, thanks, Yak. One question I have is, are you planning to add more trusted puzzle types with time, or are you allowing that to someone else to be able to do that? Or are you kind of locked in on just the three?
So with this chip, we defined 3 puzzles, but you can define, and actually the memo structure is defined in a way that allows you to add puzzles later. So if I go to the memo structure, which is not here, but here, you'll see that the way you hint delegated puzzles is the first byte is the type. So admin, an authorized admin is 1, authorized writer 2, and the oracle we define is 3. But you can always come and add another oracle with ID 4 and so on. So this chip allows for follow-up chips that define more puzzles.
Great. Okay. Another question I had is, do you guys think you're pretty much done with the reference implementation, or are you still working on it?
So it's been merged. It's currently gated by a flag just because the chip isn't final, but it was tested on both mainnet and testnet. It's working. It's done.
Oh, okay. So the reason I ask is because it's currently in draft because it's still a new chip and we're just kind of introducing it to everybody. But since you've already implemented all the code, I think we should just go ahead and move it to review, and then people can take time and review it, and we'll see if anyone has any major issues with it.
Yeah,
Um,
I'll also add that I've also been using this driver code heavily in my own development. It's been working great.
cool. Okay, so this is really far along compared with most chips when we're doing this type of call. So yeah, let's get it into review then. I'll handle that. Okay, I wanted to open up the floor to anybody else. Anybody have any questions for Michael
Yeah,
and Yak?
just to add, when I say it's ready, it means that there's a version that's working. It's been used on testnet and mainnet. It's covered by tests, but we're waiting for feedback. If there's a better way to do things or a different way that's more suited for this case, we're ready to update the reference implementations and the chip.
Yeah, and that's exactly what defines being in the review state. It doesn't have to be completely done. You can still change some small stuff. It's just that there's not going to be any big changes going forward, most likely. So thanks for that. Yeah, any questions from the audience?
Not really a question. I just think that giving a vault permission to write to DataLayer would be a very good idea, because if you're giving 5 people permission, only one of them needs to be compromised to mess with the store. If it's an M of N, then that kind of reduces the risk quite a lot.
Yeah, so I guess a follow-up to that, we've allowed arbitrary puzzles for admins and writers. So DataLayer driver, just for simplicity, uses the standard puzzle. But if you use the Chia Wallet SDK, it will allow you to have any inner puzzle for both admins and writers. So that can definitely be added without any changes to this chip.
Yeah, and additionally, like there's full control to remove them, as well. So if you find out someone is getting compromised, the owner can remove that key from the right. And the other thing is to keep in mind is like the authorized writers only have the option to modify the metadata. So in the case of an exploit, you might just get a different root hash on chain, and the owner would have to go in and make that correction, so that it actually follows the data store that's attached to it.
Okay. Other questions or comments too? All right. So, sounds like that's a no. So thanks, guys, for your presentation. And the next step then is to leave a review in GitHub, and we'll see if anyone has any glaringly obvious things that they want changed. And then we'll talk about moving it forward from there. And obviously, I know both of you are on Discord, so we've got a whole Chips channel for discussing stuff in Discord as well. And you can hit up Michael and Yak there.
Yep, we're there.
All right.
Great.
All right,
Thank you.
Thanks for giving this talk. See you guys later.
Later.